We are now smack dab in the middle of the information processing model, or the model for human memory. And what we're going to do now is look specifically at the two parts of it that are behind me. And we're going to look in particular about how do we use this in a constructive way in the classroom. So the first things that we need to understand are that there are limitations to working memory. Working memory has approximately 10 to 20 seconds, so that's really after you introduce content into in a classroom. After you introduce that content, you have 10 to 20 seconds to get the students to think about it. So engaging them in the process of thinking about it could be something as simple as alerting the class that you're going to ask a question, or it could be something like, what do you know about this topic? And you're asking them to go back into their long-term memory and retrieve something that they know and report that out. So that's one way to get them going on it, but you have to get the wheels turning immediately upon the introduction of new content. Now here's the thing. If you just do piece after piece after piece after piece of content, what'll happen is you'll overload the students. And that's what we call this cognitive load concept, getting too much out there too quickly. It's sort of like asking them to drink from a fire hose. You can't get it all. So what we'll do is, as time goes on, we try to develop capacity for understanding and learning by having them put things together and do things sort of automatically. For instance, when we talk about automaticity, this is accomplished almost exclusively by repetition. Think about the places where automaticity is most obvious. Things like times tables, math facts, things like that. Also, let's take it onto a basketball court. Things like shooting a foul shot. You don't think about, if you're a basketball player, you don't think about, okay, I have to position my feet, I have to hold the ball just so, start my my shot from my feet and go all the way up through, and I need to finish with my wrist. You don't think about all that stuff. You take the ball, stand there, and automatically do what it is that you need to do. That's how automaticity works, and that reduces cognitive loading, because if you ask students to do something that you have gone over and over and over, and they've rehearsed it and they know it, then you're not asking them to spend a lot of time in this area. You're not asking them to add this as one more of the 7 items that they might handle. While I'm on the topic of the 7 items idea, just realize that 7 items is an estimate, and for example, you probably have a capacity more like 13 items. So you're able to keep quite a bit going. There are cognitive tests that are kind of fun. You can look them up on the internet if you want to, and try them just to see how much you can remember, how much you learn. But think about this, that if you have a max of 7 items, then that number of items that you have is what you can put out at one time. The next thing that we have is this idea of chunking. And chunking, you know, some of these things, actually both of these things, we're putting education-ese on things that are more or less common sense type things. Chunking is putting stuff together so that we understand it. If you take a string of 9 numbers and you start with, you know, 0 through 9, and that string of 9 numbers, well, if you think about it as 1, 2, 3, 4, 5, 6, 7, 8, 9, then that might be confusing to you. But if you think of it as 1, 2, 3, 4, 5, 6, 7, 8, 9, now you're thinking, oh, that's a social security number. Or 10 digits. You know, take your phone number, 10 digits. But you take that as area code, prefix, and number. So really, what is that in your head? Is that 10 digits, 10 items, or is that 3 items? It's 3 items. So we can chunk things together, compress them, understand them in relationship to one another, and by doing that, then we increase the overall capacity of content that we can use at one time. If we're talking about phone numbers, then you probably could learn 4 or 5 phone numbers all the way through. The last thing, when we talk about activating multiple modalities, what we're really talking about is trying to distribute that cognitive load in a variety of ways. It's sort of like when somebody lays down on a bed of nails. If they were to lay down on a bed with 1 nail, that would hurt. But if they lay down on a bed of 10,000 nails, you don't feel it, because all of that load is spread out over all of those surfaces, over all of those support systems. Think of each of the ways that you can learn, and we'll think about them in terms of learning preferences later on. We'll think about multiple intelligences, Gardner's view of multiple intelligences in particular. But think about addressing each of those ways that you can go. Or remember when we were talking about the sensory registers, and we have all of these senses. Well, all of these senses are ways that we can get information to the brain, to the processing unit. All of those modalities can and should be used multiply. In other words, they should all be joined with other kinds. So don't just talk, but move. Don't just talk and move, but have pictures. Have things that you can hear. Have things that can be seen. Vary that, especially for younger children, especially use tactile kinesthetic. Put things in their hands. It's not just appropriate for this because we're activating multiple modalities, but it's also important from a developmentally appropriate standpoint, because if they are pre-operational, concrete operational, those kids need to have things in their hands. They're not going to be able to do a lot, as we've talked about before, with this abstraction. And essentially a lecture is an abstraction. So what we're trying to do here is we're trying to look at ways that we can activate all of these things so that we can put more and more organized content in front of students for them to bring in. Now, here's the thing. Here's what happens when they are in working memory. They have these 3 processes, which you've read about by now. We have this warning label, but here are the things that happen in here. We have rehearsal. So they think about it. They do things about it. You can facilitate the rehearsal process by requiring students to do something with the content that relates to itself. You can have them thinking, okay, what does this mean? How do you understand this? How do you feel about it? What do you think about this? Retrieval is simply the idea that if we have extant schema with which we are familiar, then what we need to do, or what we need to be able to do, is to go and find that in long-term memory and pull it back into working memory and use it. And that process of retrieval and encoding keeps going. As long as there's new information, what we do is we revise, we inform, we build our schema through this encoding process. Now, here's the difference. This is essentially an electrical process. I know you can't see that very well, but this is an electrical process up to this. This happens in our brain. Yes, things are flying around, but they're not really being stored. When we encode, we are actually storing physically memory at different locations in our brain. Schema exists in a physical form in our brain. So that's the reason that things, if your brain is healthy, then information that you've forgotten probably just isn't, you just haven't looked into your brain in the right way to find it, but it's probably still there. unless you have either chemically altered or physically damaged that section of your brain. Now we think about this. Think about a lot of drug use. Drug use that goes in through the nose goes up into the sinuses, and there are just a couple of layers of tissue between the top part of the sinus and the lower part of the brain. That stuff goes very quickly into there. If you talk to drug users, actually if you are a drug user, stop. But if you talk to drug users about that rush, that is because stuff gets very quickly absorbed into the bloodstream in the brain. That is possibly chemically interfering with memory. So there's another good reason not to do it. And then there's also, of course, the brain injury idea, where people who have injured their brains or who have injured brains may lose some of their memory, and they may lose it forever. A bad concussion can knock out long-term memory. So that's why we say that it is forgotten, but not necessarily forever. Here's the process that I want you to think about. And by the way, the metacognition, again, is our memory of, or our awareness of that whole process. Think about this, going from working memory into long-term memory. Picture yourself in the room where you are, and there's a real small hole in the wall, one of the walls. And on the other side of that wall is your long-term memory. The smaller the hole, the less frequently you have tried to access that memory. But as you begin to remember things about it, things that sort of spark a memory in you, what you're essentially doing is you're taking that hole and you're opening it up, and you continue to open it more and more until all the information that is in that room is accessible to you through that hole. So that's really what retrieval is. It's bringing that schema, that understanding from long-term memory back into working memory. When you're able to do that, then you can do the whole schema building process. So that's really the last thing that you need to think about. And that is the last implication here. Kids may say, I don't remember, I don't know. They do remember. It is there if you've done your job, and they've done their job, of course. But if that's all happened as a part of encoding, it is there. Really what needs to happen is that connection needs to be reopened. That access needs to be reopened. And to do that, you need to make sure that you have as many different touch points for that information as you possibly can. And again, I'm going right back to this. Activating multiple learning modalities. Using multiple learning modalities to get information into kids.